Hey yo, what's up, devs? Yesterday I had this autistic urge. Yeah, you heard that right, to take the same to-do app and build it using 8 different backend frameworks. Why? Because I love pain, precision, and honestly learning by doing. And the twist, I'm using React on the front end because it's my favorite library, it's everywhere. And let's be honest, everyone uses it nowadays. So today I'm going to take on a wild ride through Rails, NestJS, Django, Laravel, Spring Boot, ASP.NET .NET Core, Gene, and Phonics. We are going to see which framework can handle a simple to-do app the best. Here's our to-do app, nothing fancy. Type a to-do, click add, update it to done, delete it. Easy, right? This is our playground, and we are going to hook it up to 8 backends to see how each one handles the classic CRUD operation. So my favorite Ruby on Rails. Now we need to run Rails new to-do dash API in your terminal to generate the project structure. Once that's ready, we will move into the directory and initialize our database with railsdb create, followed by railsdb migrate to get everything set up. Next, we will create our resource using Rails scaffolding. Notice I'm running Rails G scaffold, Rails to do title, string completed boolean. This command sets up our model, control, and migration files all at once, giving us a fully functional API endpoint to start with. Now let's take a look at the generated controller. You will see that Rails has already populated the standard RESTful actions, making it easy for our frontend to interact with the database. I'm also adding some quick validations to our Rails to-do model, ensuring the title is present and the completed status is properly enforced as a Boolean. Finally, we need to allow communication between our frontend and backend. Here in the cursor being initializer, I'm setting the allowed origin to localhost, which is where my React Dev servers runs. And with that, everything is connected. As you can see, I can now create tasks in my React interface, and they are successfully handled by our new Rails API. Next, NestJS, the Node.js framework that's like an Angular's cousin for the backend. To kick things off, run nest new nest to do in your terminal to generate the initial project structure. Once the project is created, we need to add the necessary database tools. I'm running npm install at nestjs typeorm pg to bring in typeorm and the PostgreSQL driver, which will help us manage our data efficiently. Next, let us the Nest CLI to generate our base structure. I will run NestG model to-dos, followed by NestG service to-dos and NestG controller to-dos to quickly set up the core files, our task management logic. Now it's time to wire everything together. In app model TS, I'm configuring the typeorm connection for our database. I've defined a to-do entity with UUID, a title, and a boolean for the completion status. In our to-do service TS and to-dos controller TS, I've implemented the standard CRUD methods to handle our task data. Before we finish, we need to allow our React app to communicate with the backend. In main TS, I'm enabling course. And with that, everything is connected. Now any task created in the React interface is correctly processed and processed by our new NestJS API. And this one's for you. I will show you how to structure a Django backend to serve as a robust API for a React frontend. First, in settings, you can see I've added the REST framework to our install apps. When in the project main URLs, I've mapped to API path to include our to-dos API routes, keeping our API endpoints organized under a clean namespace. For our task data, I've defined a simple to-do model in models with a character field for the title and boolean field for the completion status. Using Django REST framework, I've set up a model view set in views. This is a powerful way to handle all our standard CRUD operations with a minimal code, backed by a to-do serializer to handle data transformation. Finally, with the server running, let's test the integration. As you can see, I can create a new task directly in my React application, and it seamlessly communicates with the Django backend to process the data. PHP lovers, don't hate me. I will show you how to structure a Laravel backend to serve as an API for a React frontend. Here in to-do controller, PHP, I've defined the core logic using methods to handle retrieving all tasks as well as deleting a specific task by its ID using find or fail. To ensure our frontend can communicate with the backend, I configured course.php by adding localhost to the allowed origins array. We enabled secure cross-origin communication between our development environments. And with that everything wired up, it works seamlessly. As you can see, I can create a new task in my React interface, and it's immediately handled and stored by Laravel API. Spring Boot devs, this one's for you. I started by configuring our pom.xml with essential dependencies, including Spring Data, GPA, H2 for an in-memory database, and Lombok to reduce boilerplate. I've also configured our application properties to ensure the H2 database is ready for our development environment. Next, I've implemented the to-do controller. Notice the cross-origin annotation, which I've set to localhost to allow our React frontend to securely communicate with the API. The controller release on a to-do repository with which extends GPA repository, providing us with all the standard database operations out of the box. Finally, to-do application class serves as the entry point, bootstrapping our Spring Boot context to get the entire service running. With the server up, the integration is smooth. As you can see, I can add new tasks in the React interface, and it's seamlessly handled by our Spring Boot backend. Next, ASP.NET Core. Here into the controller CSS, I've implemented the core API functionality. You can see how easily we handled standard REST operations like deleting a task by its ID using entity frameworks, find async and remove methods. The to-do context class manages our database connection, while in program.cs, I'm setting up our dependency injection and configuring cores by explicitly allowing origins from localhost. We ensure that our React development server can securely communicate with our .NET backend. And with that everything configured, it's ready to go. As you can see, creating a task in my React interface is immediately processed in the database and reflected in the UI by our new .NET API. Next, lightweight, fast and fun, Django. Here in main.go, I'm importing net/http and github.com/gin hyphen gonic /gin to set up our server routes. I've defined a to-do struct to map our data and initialized an empty slice to act as our temporary memory data store. I've implemented middleware to handle cores, ensuring our React app can talk to our Go server without issues. When using air.group API, I've grouped our routes, allowing for clear RESTful endpoints for getting, creating, updating, and deleting tasks. To keep the logic clean, I've written handler functions for each action. You can see how we use c.json to return data and c.shouldBe-bind.json to parse requests. The server is listening on port 8080. With the Go server running, it works seamlessly. As you can see, when I add a new task in the React interface, the Gin backend handles the request and updates the state instantly. And last but not least, Elixir Phonics, real-time capable, highly concurrent. To generate the project, I'm running mix phx.new Elixir to do --no --html --no --assets --no --dashboard. This command focuses the project specifically on API functionality, keeping it lightweight. Once the project is generated, we will move into the directory and create our database using mix ecto.create. When to generate our task resources, I'm run mix phx.json to do title string completed boolean. This creates the necessary context control and migration files in one go. After that, I'm updating our API routes in lib/elixir to-do web router.ex to ensure our to-do endpoints are correctly exposed. Finally, I will run mixecto.migrate to apply the database changes and finalize the schema. Inside our generated files, specifically the to-do controller, you can see how Phonics handles the incoming requests and provides clean, structured JSON responses. After building the same to-do app across all these frameworks, here's the true most developers don't want to hear. Not all frameworks are built for the future. Yeah, Django is powerful, Spring Boot is enterprise ready, but when you really zoom out and think about scalability, developer experience, concurrency, only a few stand out. For me, it comes down these frameworks, Ruby on Rails, Phonics, Elixir. But if we are talking about the future, Elixir wins, and it's not even close. Why Rails still matters? Let's be real. Rails is still king of productivity. You type one command scaffold, and you got a working app. Rails uses a third-based concurrency model. That means each request runs in a third. Thirds share a memory. It's fast enough for most apps, but there is a catch. Thirds can crash, memory is shared, scaling gets harder and harder as traffic grows. Rails is a perfect for startups, MVPs, and fast iteration, but it's not designed for extreme concurrency out of the box. Why Elixir Phonics is the future? Now, let's talk about Phonics. This thing is built different. Phonics runs on Beam VM, the same system that powers telecom infrastructure. Its concurrency model, not thirds, not async hooks, processes millions of them. Each request runs its own lightweight isolated processes, no shared memory, no race conditions. If one process crashes, it does not affect anything. This is called the actor model. And it changed everything. You get massive concurrency, fallout tolerance, let it crash philosophy, real-time features out of the box, WebSockets, channels. This is why systems like chat apps, live dashboards, multiplayer games thrive with Phonics. Now I want to make a quick comparison of concurrency models. Let's break down it simply. Rails Ruby, third-based concurrency. Node.js, NestJS, even loop single-threaded async. Django Python, traditional asynchronous, now async support. Spring Boot Java, third per request. ASP.NET Core, async third pull. Django, Goroutines, lightweight threads. Phonics Elixir, actor model, isolated processes. And here's the key insight. Most frameworks manage concurrency. Elixir embrace concurrency as core primitive. So if I had to choose build fast, validate ideas, I will go with Rails. Build systems that scale to millions, I will go with the Phonics. But you're asking me what will define the next generation of backend systems? It's not threads, it's not callbacks, it's not even async await. It's message passing, isolation, and follow tolerance. And that's exactly what Elixir gives you. So yeah, Rails is amazing, but Phonics is the future. So there you have it, 8 frameworks, 1 to the web, and countless hours of the adrenaline. Drop a comment which framework would you pick for your apps. Smash that like button if you love backend and subscribe for more developer chaos. Adios.